Dear students, greetings for the day. Today we will discuss about aircraft load and trim. It is a legal requirement and crucial to the safety and structural integrity of an aircraft that it is loaded in such a way that the specified maximum allowable weights are not exceeded and that the center of gravity as loaded will be within the permitted flight envelope and remain so for the entirety of the intended operation. Once these conditions have been satisfied, it is equally crucial that the flight crew are aware of the prevailing weight and center of gravity so that they can set aircraft equipments appropriately. These include takeoff reference speeds, slat, flap position, and pitch trim or stabilizer position. This is important to ensure that the aircraft will achieve published certified performance and that the aircraft retains expected stability and control characteristics. It is also very important that aircraft baggage and freight load complies with the restrictions on carriage of dangerous goods. It is essential that the dispatcher or other official assigned responsibility for overseeing aircraft loading specifies the loading requirement correctly and has a reliable method by which he or she can be satisfied that her instructions have been carried out as requested. Whilst modern automated systems may determine the seating options for passengers and the load disposition, effective procedures and compliance remain the only way of ensuring that what has been specified and passed to the aircraft commander has actually been achieved. Specification of the hold compartment loading is usually achieved by the completion of a loading instruction form, lifee. Many swept-wing jet transport aircraft use fuel distribution to optimize the center of gravity in cruise to reduce fuel burn. This is achieved by keeping the C of G towards the aft limits of the envelope by utilizing outboard wing, aft body or horizontal stabilizer fuel tanks. It is the aircraft commander's responsibility to ensure that the fuel load prior to takeoff is correctly distributed and reflected on the load trim sheet and maintained within the prescribed limits for the remainder of the flight. Manual load sheets involve a calculation of maximum ramp weight, MRW, maximum takeoff weight, MTOW, and maximum landing weight, MLW, whilst the center of gravity is located by marking the requisite aircraft operating weight, vertical scale, on a drop line located on a center of gravity index scale which forms the horizontal axis. If the position so found is within the areas shown as the permitted safe flight envelope, and remains within the safe area as fuel reduces to planned landing weight, then operation as loaded is possible. Manual preparation of load and trim sheets used to be commonplace, but they are now used so infrequently that recalling the necessary method can be challenging to ground staff and flight crew alike. Many younger pilots have seldom or never prepared a manual load and trim sheet or checked one for acceptance. This unfamiliarity significantly increases the risk of undetected errors with significant consequences. It is good practice to complete the manual load sheet once a month to develop and sustain proficiency against the day one suddenly becomes essential at short notice. The traditional method for ensuring load and trim compliance dates from the days when all load and trim sheets were completed manually on specific forms designed for use with each aircraft type, and is as follows. The completed document is presented to the aircraft commander. The aircraft commander checks that it is internally consistent by carrying out some simple cross-checks of input and calculated output data for gross errors. If the cross-checks are satisfactory, the commander formally accepts the load and trim sheet by means of a signature on at least 2 copies, one being retained by the departure agent and the other by the flight crew. The DCS, Departure Control Systems, process is slightly different in that only the input data need be checked and the completed document may not necessarily be signed by the agent presenting it, as he or she may have had no part in its preparation. However, in both cases, the acceptance of an apparently correct load and trim sheet does not guarantee that the aircraft has necessarily been loaded as stated. DCS and the communication facility afforded by ACARS, Aircraft Communications Addressing and Reporting System, has allowed aircraft commanders to be given substantially complete and correct loading documents with provisional status in plenty of time before STD. Final status documents with highlighted minor amendments, also known as last-minute changes, LMC, can be generated as the aircraft leaves the gate for acceptance by ACARS at any time before takeoff commences. It is often necessary to adjust the load sheet after completion. These adjustments are called last-minute changes, LMC. The LMC process is a way to enter late alterations, updates to a final manual or electronically produced load sheet, without requiring revisions to the main body or the preparation of a new document. Any LMC increase or change must not exceed the allowable underload calculation. Underload is the weight that still is available until the first limiting maximum weight is reached. Maximum mass and balance limits for zero fuel, takeoff or landing limitation of any compartment that is intended to be used. The primary risks arise from the aircraft being set up for takeoff with incorrect pitch, trim and/or takeoff reference speeds. This can arise in one of three ways: the aircraft is not loaded in the way stated on the accepted load and trim sheet, applicable to any load sheet type. The aircraft load and trim sheet uses correct input data but the output data is wrong, applicable to manual load sheets. The flight crew apply the correct load and trim data incorrectly when using it to calculate aircraft takeoff performance data, including reference speeds and schedule thrust settings. The hold load is not properly secured or contains prohibited or incorrectly packed items. Most load and trim sheets used today in commercial air transport operations by multi-crew aircraft are produced by contracted handling agents who input flight-specific data into a proprietary DCS. There are a number of commercial DCS products available. Some are operated by large airlines for their own use and then also employed to generate external user business. Other similar DCS are operated independently of any particular airline. Where DCS are used, the data input and electronic generation of the load and trim sheet may be carried out at a regional center and merely printed off, together with corresponding lifee, by the aircraft operator or the contracted handling agent employees. Note that DCS will only produce output data as accurate as the inputs, so it is important to guard against input errors. The aircraft commander must be given a copy of the completed load and trim sheet for the flight and should check and sign it, leaving a copy at the point of departure. The aircraft commander is obliged to accept that the aircraft is loaded as stated in respect of the loading of aircraft holds. However, in respect of passenger cabin loading, the senior cabin crew member usually confirms the number of passengers actually on board by means of a head count after boarding has been completed. Either actual misloading of an aircraft or incorrect use of correct load-related data for aircraft system setup can severely affect aircraft performance, stability and control. Loss of control may occur during an attempted takeoff or during subsequent flight because either an attempt, usually inadvertent, is being made to operate the aircraft outside the AFM limits, or flight crew actions to control the aircraft are ineffective because the aircraft is unable to achieve the expected performance, whether in relation to manually selected or FMS-generated safety speeds on the ESA, for example VR, or selected engine thrust parameters. One potential consequence of an error in loading or data entry is tail strike on takeoff. This will usually lead to fuel dumping and a return to the takeoff airfield, without pressurizing the cabin, and is not career-enhancing for any of the pilots, even the relief crew. Even more serious, runway excursion has been a regular result of errors of both these types in the past, whether or not an rejected takeoff has been attempted. Given the potential severity of a mistake in loading, of transferring erroneous weight and balance figures however derived, of entering erroneous data into the aircraft management systems, FMS, or missetting as speed bugs, both pilots should always carry out gross error checks. Seniority does not imbue data entry infallibility. Amongst other checks, it is vital to confirm that the zero fuel weight is sensible and then that the indicated takeoff weight is as expected.